Hello and welcome to our live discussion on RAN planning and optimization in the cloud native era. I'm Guy Daniels, Director of Content at TelecomTV. Radio access network planning teams need a faster, more accurate and more efficient way to visualize, optimize and build out their increasingly complex next generation cellular networks. Rakuten Symphony's RAN Commander achieves this by using a data-centric and automated approach. It's built on advanced cloud-native planning features and complemented by geospatial analytics and algorithms. Now, over the next 45 minutes or so, we are going to take a more detailed look at how the RAN Commander can change the way that mobile networks are built. If you have questions for any of our guests, then please send them in now. Don't delay, use the form on the page below. We also have a viewer poll for you. It's right here on the website. 1 question, 7 multiple answer choices. The question we are asking is, what are the major obstacles towards effective RAN planning and optimization? You can select whichever ones you think are the most important. And remember, you can choose more than one. We will take a look at the current voting at the end of today's live show. So please go ahead and vote as soon as you can. Okay, let's now meet our guests. And joining me live on the program today are Arun, Nair, who is VP of Product Management, Intelligent Operations at Rakuten Symphony. Dr. Petrit, Nair, Senior Member Technical Staff at the CTO Office for Rakuten Mobile, and Mina, Nicola, Head of RF RAN at Rakuten Mobile. Hello everyone, it's good to see you all. Thanks so much for taking part today. Well, let me start off by asking a question to you, Petrit. Why does RAN planning need to be deeply integrated with the other processes of a network lifecycle?
Hi, Guy. Hi, everyone. So planning or design is what the network lifecycle starts with. It is a critical part of that network lifecycle of building, planning, building, and then managing the network. It is a step that requires a lot of data inputs. And the veracity of that data is critical in order to generate plans that are good in terms of the radio network configuration and design. Starting from the physical location aspects to all the soft parameter configuration and so on. But it is not a process or a step in the network lifecycle that ends. It's performed once and it stops there. As networks get expanded, replanned, you need to go back and revisit those plans, and it becomes a part of an optimization process of the network as well. Taking input then from a live network, from looking at the subscriber experience, and so on. Without having that integration, the veracity of that data that you need in the plan creation is at risk, is always at risk, and you can lead to poor plans. Obviously, planning has been done whenever networks were built. We've done this for many years, and it's a time-consuming process. You have to take this data from different sources, input them into the planning tool, and then take the output and put into some other systems as well. Without that integration, you lose potentially on the veracity of the data due to human errors, but otherwise as well, other errors come in as well. And it is also impossible to achieve automation and intelligent control. The time that it takes to do the process manual without that integration is not going to be appropriate, I think, for the greater dynamics that we see in the networks of today and of the future, where replanning might be required a lot more frequently, where you expand the networks maybe faster, and you adjust those networks based on the needs that you have, given the simplifications that are coming from the other aspects of the technology evolution, which includes kind of open RAN, which gives you more flexibility in terms of how you deploy sites and how you can do that replanning. So having that deep integration, getting accurate data from the different systems coming into the planning process, but then also making sure that the output from the planning process is fed automatically into other systems that need that data and take action based on that data is absolutely critical for the systems of or the brand planning of today and the future.
You highlighted several times there the importance of integration. What are the major integration challenges? How do you make planning part of an end-to-end platform?
So I think one of the key challenges, as everybody that has been working in planning and optimization will acknowledge, is that there are a lot of systems used, and these are usually large disparate systems that are collecting different types of data, and often they use custom or proprietary interfaces. And bringing those together is a challenge. And I think one of the key kind of steps to address this disparity and the multitude of interfaces that are proprietary and the lack of integration, which is required to automate the workflows of planning, is really to embrace the architectures that are becoming prevalent now, which is the microservices-based architecture, the cloud-native architecture, where different applications, but not only the applications, but also their components, can have well-defined interfaces, but they also and that enable them to interact with different components or different systems in a seamless fashion. So moving towards this architecture, which can be a stepwise process, it doesn't need to be a big bang process, but moving towards having this type of architecture is key to achieve that integration. And obviously one of the other things that kind of is tied into this is that you need to have a consolidated strategy for data storage and access, because most of these processes will generate some data or will use some data as an input into the process itself.
So, Petrit, you spoke at the end there about the need to handle large amounts of data and storing this data. How can a data-driven RAN planning reduce the time and cost of 5G network deployment? Actually,
in the setup that we had in Rakuten Mobile, we've been fortunate, with how we have handled the data and how we have managed that data. And it has given us possibilities of applying a lot of machine learning by bringing these different data sources together to automate planning processes, optimization, many different things in the network as well. To give you an example, if you see the measurement coming from the network and you use that as an input, you can identify quickly and automatically where you potentially have coverage or quality issues, and you can trigger then other processes based on that analysis that you have done of that data, or if you have applied a machine learning algorithm to identify specific patterns or specific anomalies in the network, and then trigger other processes to address those anomalies. And this has led to a much more efficient, for example, coverage optimization, which Mina can talk to more as well, and a lot of savings in terms of the efforts that the engineers have to put in order to achieve that optimization itself. So taking a lot of these data that is coming from different data sources into that planning process and triggering it automatically without the engineers actually having to do it manually is a significant benefit, and it is something that we should. I mean, at this day and age, with the data that is available, to the telcos from their networks, I mean, it's something that we should use, and we should make the RF engineer's job a lot easier. So the RF engineers come into the office, they see the recommendation, the analysis that has been done from the system itself using a learning process or statistical learning, and they get the recommendations. They can take actions based on those rather than doing all the analysis themselves manually through a lengthy process with many different kind of data that they need to analyze in different systems. So that is one of the key benefits, and we've done a lot of automation, a lot of new insights that we have been able to generate through the use of different machine learning algorithms and application of AI, which has been actually quite a lot of fun as well for us in Rakuten Mobile to do, as well as making the job a lot more enjoyable itself.
Thanks very much, Petrit. I want to bring Arun in a moment, but before I do, let's go over to Mina, because Petrit, you said hopefully Mina might be able to add some words there about the impact on coverage optimization. Mina.
Yes, true. Because we have multiple data sources coming from either the predictions or even the actual subscriber data coming from their readings and measurements. So all of that, we build an algorithms on top of that to help us identify where is the coverage issue. And not only identify, but also recommend actions and even plan a site and see what is the coverage before and after adding this site, or recommend a change in parameters to improve this coverage gap. So mixing the prediction and simulation with the data, actual subscriber data, that's enable us to find more insights and find algorithms to help us fix any issue that impact the subscriber.
Thanks very much for that, Mina. And Arun, let me come across to you for your comments on this data-driven approach.
Right. I think Mina summed it up, what I wanted to say. I think the networks are becoming complex today, right? So, I mean, it's no longer the same, 2G, 3G planning that used to do back then, right? So with today's complex network, with customers being more demanding, right? Focus on service rather than just pure coverage, right? You need focus on service. Actually, the quality is important today. So with that in mind, a data-driven network planning becomes very important, so that the closed loop that we create by feeding back the data that is generated from the network, right? Be it from the crowdsourced, data sources, or be it from the, any other data source that are in the network, MDT and all of those data, right? How it feeds back into the network, gives it back, intelligence into the planning, like Mina explained on the coverage gaps, right? The coverage gaps are again is a derivative out of what we when we analyze the crowdsourced data, the actual measurements that come from are reported by our customers, right? So based on that, when it feeds back into the planning, it becomes much more accurate, it becomes much more precise, and you get a much better experience for your customers.
Thanks, Arun. That's exactly what we're after, isn't it? Petrit, let me come across to you. Are you able to tell us what sort of savings that a telco could see by taking this new approach?
I think we've described some figures. I think we've mentioned some figures before in other presentations that we have given. Obviously, it will vary on the configuration, the setup, where the telco is, but we've kind of mentioned figures of 30 to 40% savings on capex and opex as something that is achievable, and that's through various kind of means, not only through this planning process, but other kind of architectural benefits that you might get. And if you use other kind of components of what is available out there right now with the technology. But automation is definitely one of the key aspects that introduces savings in automating the workflows, the engineering costs as well. And it's not only about making sure that you have the best plan, but also making sure that you have the appropriate plan, because you get that feedback from where the subscribers are, and where it's appropriate to actually make the investment. So when we're talking about this, it's not only about the technical aspect of it, which is critical, but at the end of the day, I think for us, what we have done is that we have always emphasized, the subscriber experience. Where the subscribers are, that's where we need to kind of bring the service and make sure that they have the best experience of that service itself. So, making the right investment is a saving for sure, and the automation also then brings a lot of operational savings as well.
Sure, thanks, Petrit, and those numbers are certainly significant savings. Mina, coming across to you, how does the Rakuten solution challenge the status quo? Can you help explain, for example, how it's helped RF engineers in Rakuten Mobile to manage over 300,000 on-air cells?
Yeah, actually, traditionally, the things used to happen is that the RF engineer hop between different applications and tools. One to do drive test and see the drive test data, one to see OSS KPIs, one to see fault alarms, and completely different one to see RF predictions and simulations. So what we try to do is to bring all of this into one view. So it became a single pane of glass so that he can see the actual data happening on the field, and also in the same view he can do prediction and see simulations. So all of that different silos of data traditionally happen, we try to bring them with the help of the platform into one lake. So having all of this data, all of this view into one place, it enabled us to create more algorithms, more automation workflow, so that it can enhance the efficiency of the RF engineer. So, for example, we can give him insights about where is the coverage issue, not only based on simulation, but also based on actual drive data. Same goes for the RF planning. So now you cannot just draw a simulation by itself, but you can rely on the data is available now from the users and from the actual network element. So all of this helped us to reduce time, reduce cost, and also increase the resource efficiency. So having all of this in one place, we managed to reach almost 800 to 900 sites handled by a single RF engineer, because they have everything, just one click.
Oh, that's interesting. Thanks very much for explaining that, Mina. And can I also ask you, what is the significance of the cloud? How is it important to you in your 5G planning?
So we cannot be limited by the processing capabilities or the memory capabilities of our machine anymore. Now, with all of this data coming in from network element, from OSS, from drive test, from subscriber, and even from the data coming from the prediction, all of this massive data cannot be handled without the elasticity and scalability of the cloud. On top of that, we needed to add more algorithms and automation and workflows. So cloud helped us to integrate such automation and view all of this data easily, process it, and find actionable insight. Then close the loop with a recommendation of action or implementing of this action and compare what is pre and post. Now, 5G is very sensitive. It's a very competitive business case where you need to be very precise where you deploy 5G. And as Petrit was mentioning, we used the actual data, the traffic data, subscriber data. Because of the cloud, we managed to see where we need to deploy 5G to maximize the ROI. So cloud is very crucial in this whole flow.
And you mentioned a little bit of this already in our conversation, but can you kind of summarize for us how Rakuten Mobile is benefiting from using the RAN commander that you've developed?
So I think the first and the foremost is that bridging the gap between the RF planning engineer and the RF optimization engineer. So usually or traditionally, the RF optimization engineer is completely focused on the site health KPI, the drive test data, and so on, while the RF planning engineer is completely focused on model tuning and simulations and predictions. But what we try to do is to bridge the gap and make sure both activities are happened in the same place, so that whoever is doing optimization of the actual network can also see what if adding a new element can cause. And same for the one who is doing a prediction. He is not disconnected from the actual site that is already running on the network. So this is the first one, which is bridging the gap between the RF planning and the RF optimization. The second one, which we also discussed, is about data-driven actions and insight. Now, you cannot say I have coverage gap and that's it, but we are relying on more data coming from different sources, all mix it together to find a data-driven coverage gap or different issue, and then it proposes a solution. So all of the insights and the actions we are taking is based on actual data coming from the field. So that's also the second and very helpful insight. And of course, the last one is the cloud. As we were mentioning, running a nationwide prediction or doing multiple iterations of simulations that used to run on a long time, or even something like candidate feasibility check to run simulation for multiple candidates to select the best one. All of that have been done now with one click on the cloud. So the last one is the cloud benefits that helped us in this regard.
Great, very useful insights there. Thank you very much, Mina. And Arun, turning to you again, network planning's been an integral part of every operator's journey since the early days of GSM 2G. How does RAN Commander change the perspective or make life easier now for a network planner?
Absolutely, I guess, you're right. 2G, network planning is being done right from the 2G days. That's like 25 years back, right? Since then, people have been using, traditional, that planning tools that are there in the market, right? So how RAN Commander changes the game is bringing the paradigm shift. I think probably I'll cover that across 4 points, right? I think, point one, I think firstly, what RAN Commander does is takes the network planning to the cloud. Now, how does that help is, I think like Mina and Petrit already pointed out, bringing it onto cloud allows you to iterate across different strategies, be it your business strategy, be it your network strategies, without having to actually think about, what's my machine capacity, what's my, RAM, what's my core, what's my CPU, which used to be our worry while we used to do this 2G, 3G planning back then, on our desktops, laptops, or maybe so small servers, right? So those worries are no longer valid, right? The cloud infrastructure will take care of all your needs, right? And can help you dynamically scale up based on the demand. It could be a small geography that you need to plan, or it could be a big, a nationwide planning that you need to do. The system is ready to support that, right? So, so that's point number one. I guess point number two would be, with a platform like RAN Commander, what it brings is a single source of truth, So in terms of, say, the master site database that you have, right? So it traditionally in the planning tools, you maintain your site database, somebody maintains it manually, updating the database at regular interval. So with a platform like RAN Commander, that doesn't happen, right? Because of its integration, and the power of SimWorld the power that SimWorld brings to the table, right? So it can easily get this centralized, site database, which remains a single source of truth for all the users of RAN Commander, be it for planning, be it for optimization as well, right? And thirdly, now from the planning perspective, if you go look at talk about the consistency of the data, right, that are there, right? Like the input data, planning requires a lot of input data, be it the propagation model, be it the antenna pattern files, right? And be the clutter, the terrain maps, the RF maps that you say, right? So all these become uniform for all the users, right? Because it's centrally located and everyone works on the same, input data, right? So there is no confusion, there is no chance of human error, all these aspects go away. And lastly, with RAN Commander, what you get is also the, lot of ready, like I think Mina hinted it out, right? A lot of ready to use, on-demand scenario-based simulation tools, right? Which can help you in one single click, do a lot of activities that a radio planner does on every day, be it on a, be it validating the candidates against nominal, or be it a new site addition, impact of a new site addition, a deletion of a new site, an existing site. All those aspects, get easily analyzed with a single click instead of spending the whole day, trying to run across each of these scenarios and then trying to compare it manually. All that is taken care by RAN Commander. So I think that brings the value and that brings the change that today's complex networks need to manage today's complex network, I guess. Yeah.
Thanks, Arun. And focusing on network optimization, what makes RAN Commander an attractive proposition for CSPs in this area? How is it different from other tools that are available in the market?
I think you rightly said there are a lot of tools in the market, right? From RF optimization perspective. But the problem is today the RF engineer, who doesn't have access to RAN commander, like they rely on multiple tools. I think Mina had mentioned this, right? So there are two separate tools that are used to visualize the network. There are separate tools that are used to drive test on the network. Another set of tools to actually analyze the data, coming from the drive test or crowdsourced, sources, and there are other tools to actually optimize the network. So now, what does this bring in? This brings in, kind of, you need to be expert in a lot of tools, right? You need to manually correlate the insight that you derive from each tool, to try to get some, correlative, collective insight out of all the independent tools that you have in front of, either your laptop or anywhere, right? So, but RAN commander, how it changes that game is like it is a digital replica of your network. So I think I'll say it probably is evolving towards being a network digital twin, right? So where basically you have all the things that you need from an optimization perspective. So be it the geospatial visualization and analytics of your network, right? Looking at your sites, one click health statistics, network health of all of your sites, be it from the configuration, performance, fault perspective, almost near real time, information at probably at a cell level all the way up to the national level, in one click on the fly, right? So apart from that, there are a lot of inbuilt, smart algorithms that help you manage your coverage, interference, and capacity management perspectives, right? So there are a lot of algorithms probably, and what does all this mean? All this actually means you have, the RF engineers today can work in a much more faster, agile, and probably, way, and take much more accurate decisions to optimize a network. Especially, I think one of the things that I've seen is, sending people onto field visit is very expensive today, right? So so the better your decisions are in optimizing network, the cheaper it is for the operator to actually go and improve the network experience. So it's important to have first time right, and RAN commander will help you on that.
Thank you, Arun, and a fascinating evolution you outlined there. We are getting some really interesting questions coming through, which we'll get to in a moment. But I'd like, first of all, Arun, to ask you how the idea behind RAN Commander was turned into reality. Can you quickly walk us through this journey that you took to create this product?
Paul, I guess this tool is built by RF engineers for RF engineers. So all of us who have worked on it, right, across different geographies, nationalities, right? So when we sat on the drawing table, right, what we need to do, how do you apply, how do we change the way today's the planning and optimization should work, right? One of the key things that came out was the silos that exist between today's planning optimization teams, right? Be it due to the tools that the independent tools that they use, be it the processes, or be it even the goals that they have, right? Planning team could have a goal of actually improving the network coverage, maybe indoor coverage. It could be the overall, giving a carpet coverage, while the optimization team may have their own goals of actually going and improving network quality, right? So the way what we observed is, these teams operate independently in silos, so we wanted to break that silos. This is also something, when we spoke to RF teams around the world, across multiple operators, and also, like I said, we are all a bunch of RF engineers. We have been RF engineers in our past lives, right? So we all, when we sat together, right, the common point that came across was, yes, this is a big problem, and we need to do something about it. That's where we try to build a tool to put an end to all of this, right? So the idea, to provide a tool that is real time, that's fast, and then supported over a federated, data, right, from PM, FMCM perspective, right, and it's highly scalable. That's the thing that we wanted to bring. And then the idea came along. It should also be efficient. It should bring transparency to the table. It should be help agility, right? That I explained in the previous point, right? It should bring agility to the users, the RF engineers, right? How they can quickly take decisions for today's complex networks, right? How they can actually go back and improve the network quickly, turn around quickly, right? So that's where this RF, RAN commander got, conceived, right? I mean, like probably, in simple words, I think the whole design of RAN Commander, when we did, it was keeping the RAN engineer, be it planning and optimization of the operations, right, at the center of the design, right? So it solves their problem. It addresses all their daily needs. It makes their life easier to take accurate and faster decisions. So that was one thing. That's where the name, right, Commander for everything RAN. That's the RAN Commander. I think what better name we could think of.
Absolutely, it really explains it well. Thank you very much. Before we move on, Petrit, can I also turn to you, because we're talking about this little story about how RAN Commander came into reality. So have you got anything else you'd like to add?
Yeah, I think one important thing is that if you look around and what technologies are available, with cloud becoming prevalent, with new architectures becoming prevalent, and the possibility of getting that integration done seamlessly, I think it was a kind of a natural progression for us to take this step and to use that technology to make this paradigm shift in terms of how RAN planning and optimization is done, and really get their RF engineers a new set of tools, better set of tools, so that they can do all the planning faster and meet what is being demanded of them in a ever kind of faster changing networks that are growing in complexity. With 5G, there are new opportunities with Open RAN. There's a different architecture which gives you more flexibility, where you might you have this flexibility to replan more frequently. And as in Rakuten Mobile, we have an Open RAN architecture. We have that flexibility to adjust the network in a much more seamless fashion, faster, in order to meet the demands of the customers and address the subscriber experience. So essentially, I think RAN Commander and the timing of it is also enabled by the maturity of the cloud technology, and really bringing that technology and applying it to this area, in telecoms in general, and using the benefits of cloud itself.
Thank you, Petrit, for that. Arun, let me come back to you. Can you give us some specific use cases, perhaps, of how RAN Commander has helped engineers to significantly improve the customer experience?
Yeah, I think Mina explained earlier. I'll continue to that, right? So RAN Commander basically has totally changed the way the network planning is done, right? The data-driven way of planning the network, right? And I think that has helped, if you see, right, helped Rakuten Mobile roll out dense network in Japan so fast, right? At record speeds, right? So now coming to specific use cases, right? So there are some smart algorithms, AI-driven algorithms, that have been immensely helping the CSPs, right? So I'll cover that in probably 3 areas, right? So from the coverage perspective, from the coverage management, we have the service gap algorithms that actually identify the service gaps in the network. They try to find out the mitigation solution for those service gaps. So it could be either through optimization, or in the worst case, identifies additional sites that you need to cover those coverage gaps, right? So now these service gaps are primarily driven directly from the crowdsourced data. So they're actually customers who are getting impacted on ground, right? So it actually gives you, start recommending additional sites that you need in case the optimization is not possible from the existing sites, right? So this is one very specific use case that has really helped a lot in Rakuten Mobile, right? So apart from that, coming to interference management, so we have use cases like overshooting cells, which helps you identify the overshooting cells in the network, the bad overshooting cells in the network that can actually interfere into other cells, and then spoil their KPIs, right, and spoil the overall experience for the subscribers. So it could identify them, it could see the right value of it could tell you the right value of tilt that you need to apply to actually bring it back to in a better condition, right? So that it reduces the interference for the other cells, right? And it could actually get integrated back to the the remote electrical tilt management and all to actually go and implement this as well, right? So that's on. Apart from that, there are features like sector disoriented sectors, which actually help you identify the actual sector direction, right? Based on the crowdsourced data that we get from the field, it tries to tell you, okay, this is the ideal sector direction, or if there is a mismatch between the database that you have maintained versus what you see on the field, right? It reports you such discrepancies, which is very important to have a right database, which is important factor even for the planning, from planning perspective as well, right? So this helps a lot, and it also helps you identify things like sector swaps, cyclic swaps, and then try to mitigate that through field visits, right? And now from the capacity point of view, you have the capacity forecasting, you have the solutions which could actually tell you the locations where you need to put your small cells to actually decongest your existing 4G or 4G networks specifically, right? So where do you need to put your small sets exactly at what location so that you decongest your existing network. So these are some specific use cases that are there, right? There are a lot more there, and a lot more in pipeline that we're working on, right? So the times are exciting.
They certainly are. Thanks very much for that, Arun. Well, let's just take a pause for a short moment, and a reminder to our live audience, if you still want to ask a question but haven't yet done so, then you need to act fast. We've already got quite a few questions in, and we've got about 20 minutes or so of time remaining. Please use the form here on the website. So let's have a look at some of these questions we have received so far. Here's a good one we have in. Petrit, maybe this one I can put to you. This is not the only announcement that mentions cloud native network planning tools, which indicates there's a fundamental shift ongoing in the industry. What is different about Rakuten's approach to radio planning versus these other alternatives?
Actually, it's great to see the announcements from others as well. We have worked with a lot of partners, and we are driving, I think, this evolution towards cloud native. And as I said, I think it's nice to see that they're making progress towards transitioning to the right architecture for the future, and to enable a different way of doing the planning optimization of the networks itself. I think one thing to have in mind here is that when we talk about RAN Commander, and when we talk more broadly, perhaps about SimWorld, where RAN Commander belongs, is the fact that this is becoming part of an integral part of the network itself. It's not just about integration of different tools that you might have in your portfolio. So don't think of it in that sense, where you're integrating a certain set of tools that you are having your portfolio that were obviously legacy monoliths that you need to transition to microservices. It's really about integrating within an end-to-end platform where actually even the network functions reside. So RAN Commander is part and parcel of the overall kind of intelligent operations of the network itself. Is part of that ecosystem, because in the case of Rakuten Mobile, for example, even our CUs and DUs are on the cloud. That opens up a range of other possibilities where you also have the RAN intelligent control within RAN Commander and how it takes action as well. And then you have other components which are standardized by 3GPP, like NWDAF, which is integrated and is providing information to RAN Commander and so on. So it's not just about integrating tools, that you might have in your portfolio. However, I think it's great to see that is happening in the industry, because as long as these kind of specialized tools that are being re-architected, they have the right architecture, microservices-based architecture, they're supporting the right, they're supporting interfaces that can be used, that allows their integration into a larger ecosystem, and they can be used then in in that kind of overall platform, which is the network itself, where all the data resides, all the network functions reside, as well as this intelligence that is being added on top by applications like RAN Commander and so on.
Thank you very much for answering that question, Petrit. We've got a question here to Mina. Mina, this question is directly related to something you spoke about earlier. And the viewer asks about the user data you were referencing for optimization and planning, and how accurate is it in case of standalone sites? So the questioner wants to know, how accurate is this data in terms of geolocation?
So you can easily rely on any, for example, any drive test tool, or even not. So we have multiple tools in SimWorld, for example, like Simpulse, where we have the SDK is integrated in different applications, where we can get the user coverage statistics, for example. So we can accurately get the coverage statistics and the coverage insights from the user perspective, and all of that aggregated on the platform, and help us understand where is the coverage look like everywhere. So this is, for example, something like the Simpulse, which is part of SimWorld. Now, there are maybe something like MDT features, minimized drive test, or there are different features that's available on the RAN side that also can be integrated. And that can provide us accurate results of how the coverage look like at the end user, how the performance look like at the end user handsets. And all of that insights come together at the platform, single platform that we have on RAN Commander. And the tool with the algorithm that it have, it can draw insights and localize where we have issues, where we might have issues, and go further of recommendation of how we can fix that. So in terms of accuracy, yes, it's coming from the phones directly. Either it's a RAN feature or an SDK or MDT or different features available. All of that can be integrated with RAN Commander.
Excellent. Thank you very much for explaining that, Mina. Another question we have in here, it comes from a viewer who says, as a RAN optimization engineer who is currently working on traditional networks with proprietary hardware and software, I would like to know which aspects of my job will be influenced by the upcoming migration to a cloud-native Open RAN. Which skills should I acquire to prepare myself for the future, and how can I contribute to the network development in this new era? Interesting question there. I wonder, Petrit, are you maybe able to answer some thoughts about how the role may change and evolve?
Yes, I think one thing which I would advise all the RF engineers is really start looking at what will happen when you have more data available to you readily without having to be concerned about whether I have enough RAM or CPUs or so on. So think about what you would want to do with that data if you had that data and you can run what you would want to do with that data, the analysis that you want to do with that data without having the limitations that you have had traditionally. And obviously that kind of leads to the advice of looking at machine learning, data science, data analytics, because I think that's where I think a lot of this is going to go towards, as you have the data available. And we have a more data-driven approach to RAN planning. I think the critical input of the RF engineers is really to bring their knowledge in terms of devising those algorithms, in terms of automating then the process that they used to do manually. And that's what we have done in Rakuten Mobile, actually. And we set up a data science department actually at the beginning. Right at the inception of Rakuten Mobile, we were kind of thinking of adopting and having this data-driven approach, using the data so that we can do things more intelligently. And it's the data at the end of the day and the algorithms that allow you to do the automation. So the RF knowledge that engineers have is absolutely critical. Now they need to think about how they can apply that knowledge once they have all that data available to them. And I know that, as Arun was saying earlier, I mean, we're all RF engineers, and we've done all sorts of scripts and different programs, but the data was always limited. Now you have a lot more data, and you have a lot more resources, so a lot more possibilities in terms of what kind of insights you can get. So I think the important thing for the RF engineers is really to think how they can use that to make the networks better. And I think it's kind of a liberating experience. I think once you start having those resources and that data at your disposal, I think it allows them to be a lot more creative, allow you to be a lot more creative as an RF engineer, rather than being stuck with mundane things of, oh, okay, I ran this script, I have to now go and wait for 12 hours until it gets done, and come back tomorrow and probably it hasn't worked, it has crashed or something, whether we run out of memory or whatever. So I think that's what you should focus on, data analytics, how you can use the data and bring that RF knowledge that you have in order to get that, those insights from the data that is going to become available for you.
Positive changes. Thanks, Petrit, for those comments. And Arun, let's come across to you for some additional comments to that question.
I think Petrit summed it up perfectly, right? I just wanted to add a lighter note, probably, you may not have to go back to your VLOOKUPs, that, all RFEJs, we all, I mean, like Petrit mentioned, we all have been in our lives, using VLOOKUPs and whatnot on Excels, right? We don't need to do that, you have to change your mindset, come back to, come out of that traditional mindset. You have your software, you have the infrastructure behind you. You need to think of, smart ways to actually, smart ways of not just, doing the work, right? You can think of how new algorithms could be built which could actually help you back, in optimizing your network much more faster, right? You don't need to go back to those traditional ways with a tool like RAN Commander in place, right?
Thanks very much, Arun, for that. Mina, did you want to come in and comment on this question as well?
Yeah, just they added a lot. I will only add the last point, that when we thought about this, we thought about the user journey. So when the RF engineer come in the morning and open his machine, what he do, like what he start doing? For example, he starts looking into the performance metrics, and then maybe he starts looking in a call drop that happened here or there. So we wanted to automate all of that, or make it much, much easier. So as we were saying, we want to take the hassle away, only give you the insight that help you to take the next action. So we put the user at our center, and from there we started to develop the tool. So whatever you are trying to do every day, we want to minimize the number of clicks you click so that you can find only the result much, much faster.
Excellent. Thanks very much, Mina. Thanks to all of you for responses to that question. I'm just looking at another question we've got in, and Arun, I think this could be one for you. The questioner is asking about the business model here, and how are you offering these tools? Standalone software license, or hosted on the SimWorld platform. Is it a proprietary system that you've developed? Some questions about the product itself.
Interesting. I think, from a RAN Commander perspective, or even from the SimWorld perspective, we are highly flexible, right? So we have our own proprietary in-house systems, right? If you talk about the cloud infrastructure, we have our own cloud infrastructure, or we could even go back and host onto AWS and GCPs and all the public cloud infrastructure that you already have in the world, right? So we are flexible on that. So in this, I think what I would like to summarize is likely, we will be together in the journey, right? We will shape our solutions, the way your current network is, because there are a lot of legacy networks that are in the, legacy networks that are running right from 2G, 3G, 4G, all the way till 5, now the latest 5G, right? So our solutions would, get completely customized to the actual requirements on the ground, right, with respect to the operator that we're talking to, right? So, but yes, you can get we have all the latest and greatest available, to make your life much more easier.
Great, thanks very much, Arun, for that. And there's probably data sovereignty issues and all sorts. So probably the best advice is get in touch with you, get in touch with Rakuten, and to find out more. We've got another question coming in. Let me read this question out. What can an operator do now to improve its RAN planning if it is still years away from having the cloud platforms and cloud native processes that Rakuten has? So, for those operators who aren't so advanced in their cloud native journeys, what can they do now? Any advice or how they can utilize RAN Commander, perhaps? Anyone like to take on this question? Petrit?
Yeah, I think the most important thing is to start the journey. I think it's not a big bang approach. It's a journey for everyone. I think moving from what has been there traditionally. But the important thing is to start the journey, and the journey will take time for everyone. And I think you can use RAN Commander and bring in the data where it's available. It doesn't have to have all the data, all the interfaces in place. RAN Commander itself will have the open interfaces, so you can integrate the data easily. You might need to adapt some of the interfaces on the other side with your systems and applications that you have right now. But we understand it is a journey. We see a lot of other kind of partners and companies that we work with, where we kind of guide them as well and share our experience with them in that journey. Everybody's moving kind of from monoliths to breaking down their applications or their systems into microservices. It's important to decide on the priorities of what is most important to move to this architecture, what is most appropriate to move to the new architecture, so that it can provide the critical data that is required to enable a more efficient process. And then that journey will take time. But the most important thing is start the journey. We're there. We have the open interfaces. We are able to consume the data as it's available, or when it's made available, and then you can use the RAN Commander in order to make your processes more efficient overall. And as you proceed with that journey, as you progress with that journey, I think you will become more and more efficient as well. So the important thing, first step, start the journey. Don't wait. They can be little steps. It doesn't have to be a big step. Start with little steps and make the transition.
Thanks so much, Petrit. Great advice. We hear this so often. Just don't think about it too much. Just start making the steps on that journey, even if they're only small steps. You've got to start that journey. There's a couple more questions I would like to get in before we run out of time in the show. There's an interesting question here about using this approach in a multi-tenancy system. And the view is from Malaysia, I believe. And they're saying that they have their 5G systems on a wholesale model where a single company covers the RAN part, and there's various other selcos who share a single RAN network by buying wholesale. How will RAN Commander work in an operational environment such as that, such a multi-tenancy environment? Anyone maybe want to take a go at how this scenario would work with RAN Commander?
Yeah, I think that's an interesting dimension to it, right? I mean, like getting a multi-tenancy on top of the RAN Commander. Like, I think we have built use cases. We have references in the past. I mean, where we have done these kind of scenarios where because many of the networks are evolving, right? Like, I mean, a close example that I could give is where you have a kind of MORAN situation, right? Where you're partially you're owning the network and partially you're actually running on somebody else's network, right? So those scenarios we have captured in many of our clients, right? So it's possible. It's all about, like I said, I mean, you have to come out of the traditional mindset. With software, everything is possible. I think it's all about getting integrated to those the respective EMSs and the vendors network, right? Even from the software perspective, right? If you talk about the other I think it's from the operator's perspective, if you have multiple operators running on the same network, I think it doesn't matter. I think it's all about PLMNs and all, right? So it can be hosted. RAN Commander can still support those scenarios. and can. So we need to work. Obviously, we need to work together on this, right, to understand the exact situation, right. But yes, it's doable. It's absolutely doable.
Good to hear. Thanks very much, and thanks for answering that question, Arun. Thank you for that. Another question in: how is cost reduced in RAN planning with cloud architecture, and what are the factors which are considered while creating such a solution? So, the use of cloud architecture, how that can reduce costs in the RAN planning process. Any of our guests like to comment on this issue of cost reduction using cloud architectures?
Yeah, so I start and hand over maybe to Petrit and Arun. But the idea here is that having a data-driven decisions always help us having the right decision at the first time, or the right output at the first time. And that itself have a huge cost reduction because it minimizes as we mentioned before, it minimizes the field visit, it minimizes reiterations, or minimize even deployment of different or reiteration of deployment. So having a data-driven output, that's also important as a cost aspect. Now, the second part is that you need to do multiple iterations. You need to expand and scalable your iterations of prediction. So all of that is now easy with the cloud. So it becomes more efficient for using the cloud. Finally, the resource efficiency is also a very huge impact on the cost itself. Having everything in one place, data, insights, planning, optimization, prediction, and simulation, all of that in one place, maximize the resource efficiency. And that's also a direct hit on the cost itself.
Mina, thanks very much for that. Well, if our other guests don't want to add anything extra to that one, how about we squeeze in one more viewer question that's just arrived in. It's a very simple, short question. Can we use RAN Commander with legacy networks, with legacy architectures, 2G, 3G and 4G, not just 5G, and legacy infrastructure? So is this applicable, this solution, to legacy architectures and networks? Could have a nice short answer as well if it's the case. Petrit, Arun, let's go to Arun.
I think, like Petrit said, we have to start the journey, right? So I think even with legacy infrastructure, with your 2G and 3G, yes, we can definitely support that, right? And with a promise to evolve into the latest and greatest, right? So I think it's doable. I guess, from the legacy architecture point of view, it's okay. I think it's only about RAN Commander feeds on a lot of data and information that comes in, right? So this is more from the optimization perspective. From planning perspective, definitely you need the tool that needs to be in place, right? From the optimization perspective, you need the integration back to your PM, CM, FM, all that data has to feed back into RAN Commander. So as long as the legacy system can support feeding that data, in, if not near real time, at least the max possible, right? Whatever it can be, right? 15 minutes or 1 hour, whatever systems can support. Yes, the RAN Commander can actually still work on those data points and actually give you insights from the network as well, right?
That is good to hear, Arun. Thank you very much indeed. Well, we are out of time now. We must leave it there. We managed to squeeze in a lot of audience questions there. Thank you so much. Thank you all for taking part in our discussion today. And thank you also to our audience for watching and sending in those absolutely terrific questions. Don't forget now to vote in the poll if you haven't yet done so. Here are the live votes so far. Remember, you can vote for multiple choices, whichever ones you think are the most important. And the question we have been asking today is, what are the major obstacles towards effective RAN planning and optimization? And as you can see, there is quite a broad range of responses. So for example, 38% of those who have voted said increasing complexity of the RAN is an obstacle. Now the poll will still open will stay open for a few more days. So don't miss out on the opportunity to have your say. And if you require any further information about Rakuten Symphony's RAN Commander, or any more information on anything you've heard today, then just click on the links in the text below this video. For now though, thank you for watching and goodbye.